In this lesson, we want to talk about the binomial theorem. All right, so before we jump in and talk about the binomial theorem, we need to understand some different notation that we're going to come across. And we're going to start with this factorial notation. So if you see something like 5 factorial, okay, what this is telling you to do is to start with this number 5. And then you're going to multiply, okay, by each number going down by 1 until you hit 1. Okay, so what this means is I start with 5, and again, I multiply by each number going down by 1. So I go down by 1 to 4, and then down by 1 to 3, and then down by 1 to 2, and then down by 1 to 1. So each number until I get to 1. Just keep going down by 1. That's all you're doing. So you can crank this out really quickly, or you can use your calculator. You will have this button available to you. As long as you're using like a scientific calculator, something like a TI-83 or 84 or whatever it is now. But basically, you do 5 times 4 is 20, times 3 is 60, times 2 is 120, then times 1 is 120. Okay, so that's pretty easy. Then when we get to 7 factorial, okay, we're going to do the same thing. We're going to start with 7, and I just keep going down by 1. So I'm going to go down by 1 to 6, then 5, then 4, 3, 2, 1, so on and so forth. So you can crank this out manually, or again, you can hit the key on your calculator, and basically it's going to give you 5,040 as an answer. So now that we understand the factorial notation, it's time to look at a formula we're going to use today for the binomial coefficients, okay? So we're going to see this more in depth in the next lesson when we talk about combinations, but for right now, we're just going to take it as a given, okay? So we have this little n choose r. Okay, so that's how this is written. You might see a different type of notation. You might see this lowercase n, an uppercase c, and a lowercase r like this. So this and this, it's the same thing, just different notation. Okay, I prefer to use this one, so that's what we're going to go with. So this is, again, n choose r, and it's equal to n factorial, okay, over, you have your r factorial times the quantity n minus r factorial, okay? Let's see an example real quick. So I have 10 choose 6. So again, you could also write this as 10, and then you have the c, and then the 6 like this. Okay, so a 10, a big C, and a 6. So this is 10 choose 6. That's how that's read. In this notation, it's read the same way. Again, the same thing, different notation. So 10 choose 6 is equal to, again, I take this number here, whatever this is, it's going to go here, and it's going to go here. Okay, so I've set that up already. Then this number here goes here, and also here. Okay, so it's pretty easy to remember once you do it a few times. Just something you need to work through a few examples with. So let's go ahead and crank this out real quick. I just want to say on your calculator, you have this button available to you as well. You would hit 10, and then you would hit the NCR key like this. It's a lowercase n, an uppercase C, a lowercase r. And then you would follow that with a 6 and hit enter, and it will give you an answer. Okay, and I'll give you that answer in a minute. Let's just work it out. So what I'm going to do here is go ahead and say 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you see why a calculator is handy here, right? And then you have 6 factorial. So let me write that under here because it's going to cancel. 6 times 5 times 4 times 3 times 2 times 1. 10 minus 6 is 4, so 4 factorial. So let's write that over here. 4 times 3 times 2 times 1, okay? So we know that, let me just pick a different color here. This will cancel with this. So that's gone. And you can erase it, but I'm just going to leave it there for completeness. And then you can start canceling things here. So 10 divided by 2 is 5. 9 divided by 3 is 3. 8 divided by 4 is 2. And then really nothing else we can cancel. So let's just write here that we have 5 times 3 times 2 times 7. Okay, everything else is gone. And if we punch this up on a calculator, 5 times 3 is 15. 15 times 2 is 30, and then 30 times 7 is 210, okay? And again, you can get this more quickly by just using the n choose r key on your calculator. Okay, now let's move on and talk about the binomial theorem. So what is this used for? It's used to expand something like the quantity x plus y to the 4th power. So we already know to kind of work with this, we would go x plus y, okay, times x plus y, times x plus y, and then times x plus y. Okay, so if we went through and used, FOIL, and then after we had, more terms, we would just keep going using the distributive property. But this would take a really, really long time. So the binomial theorem is going to allow us to find our answer here really, really quickly. Okay, so there's a lot of different techniques and strategies that go with this. I'm just going to give you what I've learned over the years. I'm not going to go through the book formulas because I feel like they really confuse you. So basically the first thing is, in your book, it's going to call this exponent here n, okay, in most cases. So let's just say this is n. So we'll start by saying there's going to be n plus 1 terms, okay? So if this exponent is a 4, you're going to have 5 terms. If it was a 7, you'd have 8 terms. If it was a 12, you'd have 13 terms, so on and so forth. So we know there would be 5 terms. So let me just put 5 spaces here. So a space, plus a space, plus a space, plus a space, plus, and then a space. So 1, 2, 3, 4, 5. This is how I always do it. Now, the next thing is you are going to take whatever is in this first position and you're going to raise it to this power, and that's going to go right here. Okay, so this would be x to the 4th power. Then you're going to take whatever's in this position, okay, and you're going to raise it to this power, and you're going to put it in the last position, okay? So this is easy to remember because you're basically saying, okay, this to this is first, right? It's in the first position, goes in the first position. This to this is in the last position. It's in the last position, goes in the last position. So that's the first thing you want to do. Now, the next thing is really simple, really easy to remember. The exponents on your variables, as you go to the right, okay, or as you go to the left, they're changing by a value of 1. Okay, so what do I mean by that? So my exponent on x is going to decrease by 1 as I move to the right. So this is going to be x cubed, then it's going to be x squared, then it's going to be x to the 1st power, and then here it would be x to the power of 0, which is just 1, so we don't write that. Now the same thing goes for our y. So now we're going this way, so we would say this is y cubed. We would say y squared. We would say y to the 1st power, or just y. And here again, it would be y to the power of 0, or just 1. Okay, so you don't have to write that. Now, though either way you look at it, as you go to the right, okay, everything is changing by 1. So this went down by 1, down by 1, down by 1, okay? And this went up by 1, up by 1, up by 1. Okay, so I started with y to the power of 0. Now I've got y to the power of 1, y squared, y cubed, y to the power of 4. So you see the pattern there. Okay, really easy to remember. Okay, so once you have the kind of variable parts worked out, and in some cases you're going to have coefficients here, so it'll be a little bit more complicated. But once you have this part worked out, the next part is kind of the tricky one. Okay, so you need to find the coefficients. Now, you can work with the combination formula that we just talked about, and I'll show you that in a minute. Or you can use Pascal's triangle. So let's do a little side note here. We're going to come up here and look at Pascal's triangle. So you'll see this in your book. The main thing to remember, if you don't remember anything else about this, is that this is row 0. Okay? Everyone makes a mistake on that. Okay? You need to know the rows. This is 0. This is 1. This is 2. This is 3. This is 4. This is 5. Okay? So it starts with row 0. So what you want to do is find the kind of row that corresponds to that n value or that exponent. Again, that's right here. So if this is a 4, then when I look at this, I want the 4th row. But again, I'm starting with 0. So really it's the 5th row if you're thinking about it as starting from 1, but all the books start with 0. So it's 0, 1, 2, 3, 4. Okay, so I want this row right here. Let me highlight it for you. So I'm going to take a 1, a 4, a 6, a 4, and a 1. So let me just copy that real quick. I'm going to come back and I'll explain this in a minute. So let's just paste this real quick. And I'm just going to show you how quickly we can be done. The 1 and the 1, everything just goes in order, right? So the 1's on the ends, we don't need to write that because 1 times anything is just itself. This would be a 4 and this would be a 4. Okay, so notice how the second term and the second to last term, those are the same. And the middle term is just a 6. Okay, and just that quickly we're done. We've expanded this guy. We know that it's x to the 4th power plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus y to the 4th power. Now, let me go back and do a little bit of explaining on this Pascal's triangle because you might be saying, what in the world is this thing? Basically, the way this thing starts is, you notice you have a 1 at the top, then you have 2 1s here, okay? And basically, as you keep going down, as you go down the sides, notice everything's a 1, everything's a 1, okay? So on the outsides, everything's a 1, okay? But as you get into the middle stuff, and let me just kind of erase this real quick. As you get into the middle stuff, think about this number 2. Where does that come from? It comes from the sum of this plus this, okay? So go up to the top left and to the top right. If I look at, let me just kind of erase this. If I look at 3, it's the sum of go to the top left and the top right. So those two numbers, right? So 1 plus 2 is 3. This guy, same thing. 2 plus 1 is 3. This 4 here, 1 plus 3 is 4. This 6 here, 3 plus 3 is 6. This 4 here, 3 plus 1 is 4. You know, so on and so forth. So you can draw this thing out yourself, okay, by remembering that pattern, but it's just going to be your preference, right? I'm going to show you a different way to do this. If you have a lot of problems to work through and you're just doing homework, or maybe you're on a test and they let you use this thing, well, I would just use it, right? Because it's a lot faster than what I'm about to show you. Let me erase these coefficients and pretend that we don't have them, okay? So if we don't have them, how else can we get them? Well, basically what you would do is you would use that combination formula that I just talked about. And you're always going to take this number right here, this 4, okay, the n value as we say, and we're going to put that on the top. And let me just kind of slide this down because I'm not going to have enough room. You're going to take the coefficients. I'm just going to write it down here. So it will be 4, and you basically always take the exponent that's on y, or this second value. So in this case, the exponent on y is 0, so it would be 0. And then your coefficient here would be 4 choose 1. This one would be 4 choose 2. This one would be 4 choose 3. And this one would be 4 choose 4, okay? Now, these on the outsides are always going to be 1, so you can just get rid of them, okay? You don't need to crank that out. Again, you can use a calculator for this. If you do 4 choose 1, you're going to get 4. And if you do 4 choose 3, you're going to get 4. So I get a 4 here and here. And we can erase this. If you do 4 choose 2, you're going to get 6. Okay, so you do this there. Now, even if you're using a calculator, it is going to be a little bit slower versus having Pascal's triangle. Because again, with Pascal's triangle, I can just go up here. I can grab things again. This is row 0, row 1, row 2, row 3, row 4. I can just grab the coefficients and I'm done. Okay, I don't have to do anything. So it's just a matter of a personal preference in terms of what you want to do. Okay, let's look at a harder example, or I would say not harder, more tedious. So here we have x plus 3y raised to the 4th power. Let's go ahead and set this up. I know I would have 5 terms, right? I know I would have 5 terms. So 1, 2, 3, 4, 5. Okay, I would take this guy, raise it to the 4th power. And then as I go to the right, I'm decreasing it by 1. So x cubed, x squared, x to the 1st power. And again, this is x to the power of 0, but you don't have to write that, right? That's just 1. Then I would take, again, you've got to be very careful here because whatever's in this position is raised to the 4th power. So now you have a number involved, okay, not just a variable, so you got to be really, really careful. You would start here with 3y to the 4th power, okay? Then here it would be 3y cubed. Then here it would be 3y squared. Then here it would be 3y to the 1st power, and here it would be 3y to the power of 0. Again, that's 1, so we don't write it. So if we simplify this, we just kind of write this beneath here. So far we have x to the 4th plus, this would be 3 times x cubed y, and then plus we would have 3 squared is 9, so this would be 9x squared y squared. And then plus 3 cubed is 27. So that would be 27xy cubed. And let me kind of slide this down because we're going to run out of room. And then plus we would have 3 to the 4th power, which is 81. And then y to the 4th power. Okay, let me just erase this. We're just going to keep adding to this. We just need our coefficients now. And again, we just work with something that was raised to the 4th power. So you should remember that the coefficients are 1, 4, 6, 4, 1. Okay, so basically, again, on the outside, you can get rid of it. Here, I need to multiply by whatever's there. So 4 times 3 is 12. So this would be 12. And 6 times 9 is 54. So this is 54. 4 times 27 is 108. So let's put 108 there, and we're done. Okay, so again, if you're using this Pascal's triangle, you just go to the 4th row. Again, it starts with 0. I can't say that enough because a lot of students, they make that mistake and say, this is the 4th row, right? The one that's labeled with a 3. Okay, you want to go to the 4th row, grab those coefficients, and then just punch those in. Again, if you don't want to do it that way, you can use the combination formula. So again, you start with this. So it's 4, choose 0. Then it's 4, choose 1. Then it's 4, choose 2. Then it's 4, choose 3. Okay, then it's 4, choose 4, okay? And basically, if you crank all these out on your calculator, you're going to get the exact same answer, okay? So our result here is going to be x to the 4th power plus 12x cubed y plus 54x squared y squared plus 108xy cubed plus 81y to the 4th power. So for this one, I have 3x plus 2y. This is raised to the 5th power. So again, now this guy is going to be 5. Okay, so I'm going to have 6 terms, right? So it's always this number, which again, we call this n. So n plus 1. So here, n is 5. So 5 plus 1 is 6. So you're going to have 6 terms, and I'm not going to space it out. I'm just going to kind of do it. I'm going to take this guy and raise it to the 5th power. So 3 to the 5th power is 243. And then times x to the 5th power. Then you would have plus, you would have, let's just go down. We would have 3x raised to the power of 4 So 3x raised to the power 4. 3 to the fourth power is 81. So you would have 81 x to the fourth power. And then plus, I'm going down by 1. So now I would have 3x cubed. So 3 cubed is 27, then x cubed. Then plus, let me just kind of drag this down here, okay? So I'm going to do 3x squared, so that would be 9x squared. Then plus, I would have 3x, right? It would be raised to the first power. And then lastly, you would have your 3x raised to the power of 0, which is just 1. Okay, so you can leave that off. Now this guy right here, again, I take 2y, I raise to the fifth power, that goes last. So 2 to the fifth power is 32, so that would be 32y to the fifth power. And then as I go this way, I would have what? 2y to the fourth power. So let me write this up here. So 2y to the fourth power. I know this gets real messy. 2 to the fourth power is 16, and then y to the fourth power. So you're going to have to multiply here. So 16 times 3 is 48. So you would have 48 x y to the fourth power, okay? And then as we move this way, now I'm working with 2y cubed. So 2 cubed is 8. So this would be 8y cubed. So 8 times 9 is 72. So you would have 72 x squared y cubed, okay? And then as I move up here, now I'm going to have 2y being squared. So that would be 4y squared. So let me just write y squared there. 4 times 27 is again 108. Let's write that in. And then as we go here, now I'm going to have 2y to the first power. So I'll just put a y there. 2 times 81 is 162. And then here we don't need to write anything. You'd have 2y to the power of 0, which is just 1. Okay. So again, you can go through to get the coefficients. You would start with, 5 choose 0, which is 1. So you can leave that off. And then you would go to 5 choose 1, and then 5 choose 2, and then 5 choose 3, and then 5 choose 4, and then finally 5 choose 5. Okay, so this would be 5 choose 0, which is 1. This would be 5 choose 1, which is 5. Okay, so I'm just going to put a 5 there. This would be 5 choose 2, which would be 10. Then for 5 choose 3, you would get 10 again. And then as we get 5 choose 4, it's always going to match this. So this is going to be 5. Then as we get to the end, we have 5 choose 5. Again, 5 choose 5 and 5 choose 0. Those are each going to be equal to 1. So you can get rid of those. Okay. So let's just get rid of this and let's do our multiplication. So this stays unchanged. 5 times 162 is 810. So 810. 10 times 108, let me just slide this down, would be 1080. So 1080. And then 10 times 72, let me just slide this down real quick. 10 times 72 would be 720. So this would be 720. 5 times 48 would be 240. So 240, and that's it, we're done. So we get 243x to the fifth power plus 810x to the fourth power y plus 1080 x cubed y squared plus 720x squared y cubed plus 240x y to the fourth plus 32y to the fifth power. Now again, if you wanted to use this row here, row 5, that's fine. You have 1, 5, 10, 10, 5, and 1. Again, what we just saw. All right, so let's wrap up the lesson and talk about how to find a specific term. Some books will call this finding the kth term of a binomial expansion. So let me just read this problem and I'll give you a simple little formula that you can use. So we have the quantity x plus 2y to the seventh power. We want to find the third term. So you could use the binomial theorem, okay, and kind of write all the terms out. You'd have 8 of them, right? Because this is a 7, so you'd have 8 terms. And then go through and get the third one, right? But that would be kind of a waste of time because you have this little simple formula that you can use. So what I'm going to give you is I'm going to say that this is n. Again, I always refer to that exponent as n. This 3 here is going to be a value of k. Okay, that's what we're going to call it. So if you were finding the third term, k is 3. If you were finding the 10th term, k is 10. If you were finding the 21st term, k is 21. Okay, so on and so forth. So what you're going to say is that the coefficient is n choose k minus 1. Okay. So in our case, n is 7. So n, let me write this here. So n is 7. And then k is 3. So 3 minus 1 is 2. So you're going to have 7 choose 2. That's the first part. Then times. You're going to have the x, which is whatever's in this first position here, raised to the power of n minus the quantity, okay, k minus 1. So this is inside of parentheses here, so be very, very careful to just plug in and evaluate it with it inside of parentheses, okay? So if I plug in and say this is x raised to the power of 7 minus the quantity, okay, you would have 3 minus 1, okay? So this is going to be what? It's going to be 7 minus 3 minus 1 is 2, right? Because you do what's inside of the parentheses first. So you would have 7 minus 2, and 7 minus 2 is 5. Okay, so that part's done. Then we would have y raised to the power of k minus 1. Now in this case, for our y, what's our stand-in, we have 2y, right? So you have to take whatever's in that second position, okay, and do this to it. So I'm going to take this and say it's times 2y raised to the power of k is 3 minus 1. So 3 minus 1 is 2, so this would be squared. So if I square 2, I get 4, and if I square y, I get y squared. So this would be 4y squared, okay? And then I have 7 choose 2. Let's just go ahead and do that. You punch that into your calculator, you get 21. So you'd have 21 times 4, which is 84. So you'd have 84x to the 5th power y squared. Okay, let's look at one more of these. Let's try to do it without the formula. I'm going to reference it. But basically, we have y plus 2x raised to the 6th power. Okay, we want to find the fourth term. So again, just think about this in your head. This is k, and this is n. Okay, so just get used to that and just basically say, okay, what do I need to do? I want to do n, so this number right here, k, which in this case is 4, minus 1. So 4 minus 1 is 3. So 6 choose 3. So that's the coefficient part. Then what's this part here and here? Well, remember, I take this guy, okay, so I take this guy, in this case it's y, and I raise it to the power of n, which in this case is 6, minus, and this is important, you use parentheses, the quantity k minus 1. So 4 minus 1, okay? So 4 minus 1 is 3, okay? So we're going to have 6 minus 3. So 6 minus 3, which is 3. So we'll put y cubed here. Then the next part is going to be this guy. So it's going to be times, you have your 2x raised to the power of, again, k minus 1. So in this case, k is 4. 4 minus 1 is 3. So 2 cubed is 8, and x cubed is just x cubed. So we put times 8 times x cubed. Okay, so let's do 6 choose 3 real quick. And that is going to give us 20. Okay, so this is 20. And so what we would say is 20 times 8 is 160. So I can write this and say this is 160. Okay, let me just erase this as I go. Times y cubed x cubed. So that would be your fourth term when we expand this.